welcome all of you, and you are watching the series of videos based upon the actual interview questions which you will get in DRDO interview. As I told you earlier also, DRDO interview is a very interesting interview. They ask you questions which need some kind of thinking. From where they ask you question, they check your deep understanding of the subject. The question was like, how do you measure the height of aeroplane and the speed of aeroplane when it is flying? You know, aeroplane flies approximately at 30,000 feet, maybe 36,000 feet or 10 kilometers, 12 kilometers, that is the height. In the mid-air, when it is cruising, when it is flying, that is the height of the aeroplane. And typically the speed of aeroplane is 1000 kilometers per hour, 900 kilometers per hour, 800 kilometers per hour. That is the typical speed. Now what devices do you use to find out the speed and height of the aeroplane? Both the devices are from fluid mechanics. Now that was a question which was asked, and there is something which is called pitot tube. There is something which is called pitot tube. You know what principle it is based upon? Pitot tube. Suppose I want to find out the speed of particular, let me make this diagram for you so that you are in position to understand the meaning of this. I am giving you one pitot tube. This is the typically how the pitot tube will look like. Okay. Let us say there is a fluid which is flowing, and then when the fluid is flowing, there is a U-tube manometer. Maybe you can see U-tube manometer. This is the U-tube manometer. Maybe this is mercury, if I can say, this is mercury, and liquid is flowing, and let us say the liquid which is flowing is a water in this, let us say, and I want to find out the speed of the water, with what speed this water is flowing in this. So this side I get stagnation head, this side I get static head. So this one is giving me some information about static head, this is stagnation head. You know what is the meaning of this. And V square by 2G, the kinetic head, is difference of stagnation head and static head. And this stagnation head, difference between static and stagnation head, can be obtained from this particular U-tube manometer. This is a very simple principle of pitot tube. That means pitot tube is used to find out the velocity of flow of a fluid. Now if you see the diagram, if you go on internet and find aeroplane, how the speed of aeroplane is measured, or if you type on the Google pitot tube on the side of pilot, I mean outside the window of pilot or something on the aeroplane, front side mein there is a small pitot tube, and as the air velocity is flowing, think of this, the velocity is air velocity, and you have made some arrangement of pitot tube such that the mouth of pitot tube, the opening of the pitot tube is towards the incoming air. The air comes inside and the manometer is there in U-tube manometer, and that is going to help you to measure the velocity of flow of air. And you will agree with me that air is static there, it is the velocity of the aeroplane actually. So the velocity of aeroplane in the mid-air can be calculated using the pitot tube. Principle of pitot tube you should know. What is stagnation head, what is the static head, and how do you calculate the kinetic head. And it will also ask you how do you install the pitot tube, have you seen the pitot tube. So I will advise you that go on the net and see pitot tube कैसे लगा होता है उसमें, तो आपको उसका idea लग जाएगा. And then next question is, how do you find the height of the aeroplane then? At what height it is flying, how do you find that height also? And let me tell you, let me give you a hint for here, hint at this particular point. Can you find out the pressure? Because if you can find out the pressure, let's say aeroplane is here and this is the ground. You know what is the pressure at ground? So you know what is the height. I want to find out what is Z here, right? So can I find out the pressure at particular point in the aeroplane? Can I find out the pressure? You can think of using Bernoulli equation and find out the pressure at that particular point, at that particular height. Again manometer can be used. Using manometer, because pressure inside aeroplane is already known, pressure outside aeroplane, can you calculate that? So if suppose I give you two locations and suppose I connect some kind of U-tube manometer at these locations, something like this. If I connect two locations, something like this, state 1, state 2, and the manometric limb difference Z gives me the difference between the two pressures P1 minus P2. P1 minus P2 by rho G, whatever. I mean, this is the rho of mercury, this is the rho of fluid here, this is the rho of fluid here. So if I give you 2 points and I want to find out the pressure difference between the 2 points, the differential manometer is used. Now what are these 2 points? One point can be inside the aeroplane, that is atmospheric pressure. Another can be, why atmospheric pressure? Because we people are human beings are sitting inside, so pressure has to be atmospheric pressure. They maintain the pressure. Pressure outside can also be gauged, the pressure outside can also be measured, and the difference of these two can be measured on differential manometer in terms of limb difference of the fluid. Now if I find out what is the pressure there, then there is something which is called hydrostatic law. Don't you know the hydrostatic law? From there you get an idea, P, as you go up in the height, hydrostatic pressure formula can be used. But remember one thing, that density is also going to change here. Density is not going to remain same. dP by dz is equal to plus minus rho g, specific weight. Now rho is not constant here. As you move away from the surface of earth, this is the surface of earth. Now rho here will not be same as rho of air here. Rho of air is the gas, so it is compressible thing and its density is not going to remain same. As you go up, then pressure decreases, it is a negative now. So as you go up, the pressure decreases. Here it is atmospheric pressure. Now as I told you, using manometer I found out what is the pressure here, P I know. So delta P is known to me, delta Z I want to find out, and now I can find out what is the density of the air. How I need to do that? P is equal to rho Gz. This is the ideal gas equation, right? You may be knowing this, how it is calculated. And what is rho? P by Gz, right? And if I put value of rho here, it comes out to be dP by dz is equal to minus P by this Gz into G. It gets cancelled out, rho G. So this is rho G is P by Z. So this comes out to be minus P by G. So this is dP by P is equal to minus dz by Z. So some relation will come, log of P is equal to minus log of Z plus log of C, constant or something like that. From there you can further analyze this particular process. So they want you to go forward, they want you to even tell that this hydrostatic law, how this is used. Plus minus लगता है इसमें, liquid के नीचे जाते जाओगे then pressure will keep on increasing. अगर ऊपर जाते जाओगे atmosphere में then pressure decreases. So dP by dz plus minus rho g, specific weight. Rho for liquid is constant, water के नीचे जाओगे rho is assumed to be constant. It's very simple then. But as you talk about gases, then rho is changing. So if you assume air to be ideal gas, आपको ideal gas equation use करनी पड़ेगी. Rho की जगह पे आपको और rho P is equal to rho G Z whatever आप जो ideal gas equation आपको, sorry this is not ideal gas equation, sorry, you have to PV is equal to MRT. I'm sorry I made all this mistake. So this is not the right expression. This was hydrostatic law I was using. So this is the ideal gas equation. Yeah, P is equal to rho RT. This is, I made the mistake. Mass per unit volume. This is ideal gas equation. PV is equal to MRT. R is the characteristic gas constant. So I want to use rho is equal to P over RT. P over RT. So you go there. dP by dz is equal to minus P over RT into G. अब यहाँ से dP by P can be minus G by RT into dz. Now I need to assume that temperature is constant. Suppose I assume temperature is constant, then this can be log of P is equal to this. That formula will come. But if I assume that yes, temperature is also following something which is called a lapse rate. You know what is lapse rate? Lapse rate means with every 1 kilometer 6 degrees centigrade temperature decreases. The temperature decrease with every kilometer as you go up, temperature decrease is 6 degrees centigrade. If you assume that kind of lapse rate, then you can put that lapse rate here for temperature at particular height. That means temperature also varies with height. So T lapse rate can be used here in the terms of T, and we can put the expression of Z here. You can basically think of pursuing in that particular direction. Then from here you can calculate it, dP by P, that is log of P is equal to this particular thing. So you can approach that problem from here also. So how the pressure is changing. Now what we want to find out is the height at which the pressure is this. No, you already know what is the pressure at that point, you already know what is the pressure at atmosphere, you already know what is the temperature at particular point. From there you can calculate what is the height at what the plane is cruising ahead. I don't want to solve it further using lapse rate, that is not our purpose. Our purpose was like what is the pressure, what is the height at which this is cruising as of now. So height at which we are cruising can be calculated in two ways, either through the lapse rate. So temperature thermometer already you have, from temperature you can measure. As I told you that for every kilometer 6 degrees centigrade is reducing. So you know that temperature at presently Earth's surface where you are cruising is this much, and at this point temperature is this. So from lapse rate you can calculate height. Another thing is using manometer, from difference of the pressure you can calculate what is going to be the height of the aeroplane. So this question, when it will be asked to you in the DRDO, what is the height of the plane and what is the speed of the plane, answer is pitot tube can be used to find out the speed of the plane, something like this, air velocity, and height can be found out from the lapse rate, which says that with the height how the temperature is changing. So temperature from thermometer I can measure, or I can measure from pressure, manometer I can use and measure the pressure which is there at that point, and hydrostatic law can be used to measure the height at that particular point where the pressure we already know. But when you use hydrostatic law, my point is you should be very clear, hydrostatic law में you cannot use rho as a constant. rho के लिए तुम्हें आइडियल गैस इक्वेशन यूज करनी पड़ेगी, उसको टेम्परेचर की फॉर्म में तुम्हें कन्वर्ट करना पड़ेगा, लैप्स रेट तुम्हें लगाना पड़ेगा. दैट इज हाउ यू कैन कैलकुलेट इट. सो द अप्रोच विच यू फॉलो, that is something which is very very important in DRDO interview. Please follow these kind of approaches whenever you solve some question in interview of DRDO. You just tell them this is the approach at which we have to proceed, and then you get the mark. Even if you don't reach the answer finally, marks will be given to you for the approach which you follow. I hope you understood the question, and please prepare in this line. Thank you.